everyone. How are you? Another Monday night and another edition of the Physicist and Philosopher. Hello, Dr. Albers. How are you?
I'm very well, thank you, Wayne. And how are you?
Well, any better, I'd be guilty. But then again, I was never that innocent. Is it on your end or my end that I can hear that?
Oops, sorry. I think that's me.
Oh, no, that's all right. Hi, Brandon. Hi, Claudette. How are you doing? Chris, good to see you. Mad Hatter, how you doing? Haven't seen you here for a little bit. Cove Man, Peace Man, Don, Stoll, how are you doing? Hey, folks. Well, so Claudia, it's still cold where you are at. I hear.
Yes, it was miserable outside. There was to me it looked like snow and rain, but people here call it flurries.
Yes, and flurries are relative. I've seen 12 inches of flurries.
Wow.
Yeah. Because somebody missed it. Hey, Brian. Hi, Sue G. How you doing? Good to see Bonnie. Good to see you. Gravity Storm. Love a Pet. Good to see you as well. Hello, everyone. So now from where you moved from, which was like the tip of the world, next to Antarctica. I mean, as they would say in East Tennessee, hey, Brian, you tell me if I'm not speaking truth here. They would say, well, that's just a fur piece down the road. Seriously, yes. I'll digress. I lived in Knoxville, Tennessee, and worked in our facility was located in Clinton, Tennessee. And a lot of the workers were women. And our customer service representative, whose name was Alice, had a very strong Appalachian dialect. Now, Claudia, you're close to where Appalachian is. And if you ever go with Scott and y'all visit around, what would be Eastern Kentucky up into the West Virginia area, that is, hi, Brandon. Well, thank you. Thank you very much.
Yeah.
They have a distinct dialect. And so I had a number of clients in New York. True story here, folks. You're going to love this, Claudia. And the woman who was the art director was Jewish. She was, what we would call, she didn't probably tell you. She says, I'm from New York. She calls down there to speak to Alice, and we were needing some approvals so this could go to print. And the client asked Alice, well, what color are we needing to approve? And Alice says, yeller. And the woman in New York kept saying, why are you yelling at me? And Alice said, no, you need to approve the yeller. And now this was before cell phones, folks. We didn't have cell phones back then, we didn't have computers. I mean, so I'm on the road, right? We were pretty much up to date. I had a phone in my car, and I also had a pager. Well, the next thing I know, this thing is buzzing, one from Tennessee and one from New York. This woman from New York's going, what the hell is going on? And I'm going, what is the problem? She said, that woman can't speak English. And I said, what is the problem? She said, she kept yelling at me. And she said she wanted me to tell her to quit yelling at her. And I said, what? So anyway, true story, actually happened.
Oh, and my goodness.
It just tells you how we get communication just all messed up.
Yes. Sometimes it has to be written down to be understood.
Yes. And then, even then, it sometimes can get really confusing.
Yeah.
I'm guilty of it. I used to be a person that I would react like that very quickly. And, in one way, it's good in leadership, and the other way, it bites you in the ass every time, the butt every time. Excuse me. And so when someone would send me, for instance, when texting became where people were starting to communicate, I'd look at this and go, what are you saying? And I'm sure it's the same way with you in class with students.
Yes. I try to repeat things. I used to try and repeat things if I had the time. I would ask them, do you have a question? But most of them would only come to me afterwards with the questions. Most of them were too shy to ask in class. So after the class, I'd get some idea from the questions where the problems were. So the next lecture I would start with those.
Okay. Now, go ahead. Yeah. Go ahead, doctor.
Yeah, because I didn't think there was any point in just keeping on lecturing if the students didn't understand the basics.
Good point.
There was no point. So, well, there would be a cutoff eventually because I had to cover the material. But I really tried to spend as much time as possible dealing with the problems before continuing on.
In complex problems that you would present to your class in their homework assignment, I'm asking you, now I never got to finish school, but I did have the opportunity to sneak into a number of classes at university.
Good.
And helped a number of people in their assignment. Here's my question. In your class, and was this theoretical physics? Was this what the class was specifically, or was it a subdiscipline of theoretical physics?
Well, it was my course that I was assigned was first year major physics. So this is when you start training people that are going to eventually, well, quite a few of them, we hope, are going to do a PhD in physics eventually.
Go on to get their doctorate.
Yeah. So,
so what do you, this is wonderful. And I know a lot of people are getting benefit from this as well. So you have the first year of students coming in to basic physics 101, I would call it. So that does require a certain discipline of thought. So my question to you is that when you would assign a homework assignment, how much did you account to the student reasoning out how they arrived at the answer?
Yes, you see, the training is specifically not so much about the content, but the thinking involved. So I especially put things in my course that were designed to train the mind to think in a certain way. And as I think I explained this before, but it has to be in a step-by-step way. You have to learn to simplify. You have to learn to ignore certain things. And this is actually very difficult because when people read the question, the whole material seems to float around in your mind. And the first thing I had to try and get them to do is to draw something, to draw a diagram. That's very difficult to get students to learn to draw a diagram because as you draw a diagram, you concentrate on one thing at a time. Because the human mind, in order to build a whole picture of what's going on, has to interconnect things, but it can only do so by connecting one at a time.
Interesting.
So when you become very familiar with the principles you're applying, then you may be able to consider 3, 4, or 5 at the same time. But especially in the beginning, you have to concentrate on one small point, and then you consider another one. You consider how the two are interrelated. And so I had to get students to draw that diagram. And my research was actually, I was researching how the brain solves problems.
Interesting.
Yeah. And I used to explain to my students this way. Your framework in your brain has been built up since you were born. But when you're trying to solve a problem, and problem is partially creative process, because you have to form a new pathway when you're solving a problem that you've never seen before. And this is a real problem. So it's like standing at the edge of a cliff, say that there's, or canyon, and there's no bridge across. Your brain has to develop that bridge. So you stand there at the edge of this canyon and you look down at the hole and you don't see anything. You look back at what you know because you read the question. And then you demand of your brain an answer.
Excellent.
And when you do that, and I used to say to them, just calm down, wait, your brain is designed to do this. The brain starts churning and trying to figure out a way to build a bridge across.
Interesting. I would have been a good student. I design software systems. Mm-hmm. And when I began, I've designed 2 of them. And the thing that I was taught is the same principle. You know, you have to basically have what we would call the primary reason for the function of the software. What's it going to do? How is it going to accomplish it? And some of the most difficult part about designing software systems is always designing what we would call the UI, the user interface. Because engineers think one way, but customers who are using the software think completely different. The customer thinks in applications of not intuitiveness, but leading. In other words, the user interface is supposed to lead you to your eventual conclusion of where you want to end up at. Where people like myself, it's much more intuitive, you know. So I think I would have been a very good student of yours, Dr. Albers.
Yeah, I think programming and physics goes very well together because it's also in programming, you have to simplify things, you have to categorize things, you have to build on one thing after another. And it's the same process in solving problems in physics.
Yeah, I mean, you know, as you and I were talking right now, I'm thinking about the last payment system I designed. And when you're doing schematics, it's always coming down, no matter how you begin to branch off from a particular node or pathway, you have to ensure that that's not going to corrupt the primary mission. And I can see where physics would force you to discipline yourself when you come up with an hypothesis. Well, does it meet the criteria of what the problem is?
Yeah.
See? All right, guys, you see, I'm going to go to the front row. I'm just telling you.
Yeah. I used to tell my students, you are here and I am training you and I'm helping you become a physicist. Or I would say to them, I believe I'm here to train physicists. So I started telling them from the beginning they were physicists in training.
Oh, I love that. And, you know, as you were just talking, when I think of the word now, physicist, I begin to think of mental gymnastics, mental physics, physical attributes of working the brain. And am I correct? I know I am. But, you know, when a new person is introduced to a new idea, new concept, that it takes at least 21 days to begin to lay the synaptic neural pathway for those neurons to actually become a habit, correct?
Yeah, I think a habit is like that, but with learning, it's not always like that.
Okay.
It takes different amounts of time. The thing is, the moment you can connect a new concept to old concepts that you know very well, it's learned. Okay. As long as you can connect it easily because you understand it and you see how it's connected to what you already know. Sometimes solving a problem takes a lot of thinking. So even what I'm doing now, my own research now, I sometimes have to think about things for for a while, but I just turn it in my head over and over and over again until I start to figure it out. And this is also why it works so well for me to write, because as I write, I slow my brain down. And by slowing it down, I can consider the little intricacies one at a time. But one big thing is having confidence in your own thinking ability. So a physicist, by going through all those years of training, all those years where the mind is trained to think in the same way, especially when you get to the fourth year, when things start to come together and you start to see an overview of the whole of physics, which you never do again because you then go do a master's and you specialize. When you start to realize that you understand how to apply the principles. And then you never look back again because now you realize that you can think.
I love this. Can I ask you a question? When you are contemplating a problem, do you speak at yourself in the, for instance, second or third person in order to address to yourself? In other words, do you repeat the problem, or do you begin to use other parts of your brain in seeking, approaching with a new direction for a solution?
I don't speak to myself that much.
Okay.
I do put the things that I'm talking about into words, but I'm not talking to myself about it. Like I would say, okay, so the sun goes dark. What does that mean? Does it mean that it does this? Does it mean that it does that? And then I consider it, I weigh it in my mind. And then I would say, okay, so if it goes dark, and that is because it's electrical in nature, this is the kind of process I had to go through anyway. Does that mean that there's no gravity? Then I'd have to turn it around in my head again and think of the options involved in the process. Which one is logical? Because as you decide on one pathway, okay, so it's electrical, there's no gravity. What does that mean for the universe, for our planet, for the solar system? So I have to consider all that until I get to a point where every consequence is logical.
Excellent. Excellent. I understand that perfectly. Again, designing software as I do, that's exactly in while you were telling, what I do is that I put it into compartments. You know, if I have something that I just cannot get my head around, I'll put it into a compartment and I'll set it up over here. And I'll tackle what I can at least know that I can begin to solve within my mind. And it seems that once I have one domino down, it seems to lead to the next answer.
Yeah. And I'm always guided by the observations, because it's not just a matter of logic. It's all built on observation, because what is true is not necessarily the theory, although I have to use some theory, but I have to fit it to the observations that we have of the stellar cores, what's happening with the sun. And this is where most physicists fail. They fail to consider the observation as primary. They consider the theory to be primary, and they throw away the observation. And then they get to the wrong conclusion. That's why the whole of physics is wrong. Just about.
Interesting. I wonder if it would help physics if you approach this like, you know, ready to launch a new product. So, you know, you don't go out there and launch the product unless you do some testing. And typically what you want to do is get a focus group. And then that focus group then becomes basically the guinea pig. You know, you'll test this out, you'll test that out. But it seems like physicists have a problem with that. It seems like they are reluctant to go outside of the box, so to speak.
Yeah. Yeah, my method is actually in a way similar to Einstein's, except that I have made, Einstein did thought experiments to come up with his theories. He thought about it as well. And basically, I do the same thing, but I always rely on the observations. I'm always looking for the observations. I'm always looking at the pictures of what these stellar cores are doing. Look at these connections. How do they make the connection? Look at how they move. And trying to understand things based on that.
You know, I met the great Steve Wozniak, and was out at a conference in San Diego. And of course, you know, when you begin to think about what he did with Steve Jobs and the parallel path of where they were moving, and then what you've got was Gates and Paul Allen in their tracking. And I remember Steve Wozniak saying that that's how they began to look at it. He said he saw it as blocks. Does this block fit in that block? If it doesn't fit the block, then what block was going to make, you know?
That's interesting. Yeah, as you know, I did some programming when I was a student. I learned to program in Pascal and Fortran.
Okay, yeah.
That was a long time ago.
A long time ago.
Mainly Pascal. Fortran is similar, but not quite.
Yeah. You know, the great thing is that when I got to the CEO position, and, you know, my job was out raising venture capital, I didn't have to do that anymore. You know, now my butt was dragging because, you know, many a times, you know, I would catch a flight back from San Jose back to Austin. And, you know, I got to know that red eye. And so it was always the next morning because, you know, you have to meet with the engineers. You got to see, you know, how's the software going? And, you know, then you get to ask all those questions, you know, it's like, well, why this is good.
Is that how you learn to interview people?
Yes. Yes. The largest company I had almost 200 employees. And, you know, you have to have structure. And when you do this from a startup, you know, it takes on complexity. You know, the first time you get your first Series A investment, I got to tell you, it's kind of really cool to really hold a $10 million check. That wasn't mine, but I got to hold it.
Yes.
I got to deposit it.
That sounds like fun.
Oh, yeah. Well, you know what? And that lasts just as long as the champagne is flowing, because then the next morning, now you've made a deal, and, you know, things begin to change very quickly. But yeah.
But now you have to deliver.
Yes, you do. Yes, you do. And, you know, but I love it. It is really the thrill of the chase, you know, because when you get into startups, Claudia, the thing that you have to realize is that the odds are already overwhelmingly against you. And particularly if you're getting into an industry in technology. Now, in my case, where payment was concerned, that's a very expensive thing to get involved with. And it requires many times tens of millions of dollars to really launch a successful company. And now that time has passed. What I'm seeing now with the venture capitalist is where we're going down, and it's kind of a weird area, but it seems like a lot of it's moving to the neural net thinking. You know, Google's working on a new application where you can actually think to the computer. Now, I don't know what kind of interface. I can only begin to imagine what type of interface. But this is why I love having you on the show, because from a physicist's point of view, I can get a disciplined mind that is just that. And it's wonderful to get your perspective on that.
Yeah. Thank you.
Speaking of, go ahead.
It's a pleasure actually to talk about it because I have been interested in thinking my whole life. I think when I started, when I moved to South Africa, I was 11 years old and I couldn't speak English at the time.
Mm.
And I told myself, okay, in order, and no one told me, I thought the way I'm going to learn English quickly is by thinking in English. So even though I didn't know many words, I decided I was going to think about everything in my life in English. And then if I didn't have the word at the time, I would put in the Portuguese word, but then I would listen in the environment for that word so I could from then on have that thought in English.
Wonderful. You know, when you started saying, I found out that your native country was Portugal, I always enjoyed the movie. And of course, I had it with John Travolta. Come on, folks. It's where he had the brain tumor.
Oh, that one. I remember that.
Yeah. Phenomenon. That's what it was.
Yes.
And remember his friend that the woman who he eventually fell in love with, she was Portuguese.
Oh, and I couldn't even remember that.
Yeah, remember, because John Travolta began to speak to it in the tape recorder, a word. And that's how his friend began to think about, how would I think about this in Portuguese? You know, I often wonder that where people have such a problem sometimes accepting foreign ideas, that if sometimes they would stop and instead of thinking through their point of view, stop and think about the person who point of view you may not agree with.
Mm-hmm. I mean, that's right.
What I have seen in some of this is just ridiculous when people try to harm others just because they have a difference of opinion.
I know.
You know, the best fascination of my life has been the ability to step down off my high horse and, as I tell myself all the time, suck it up, cupcake, that, the world doesn't begin and end with you. The reason why I'm here, that now I'm figured it out, is to enjoy the experience, to enjoy every person I meet, and you and I consider as a very good friend now. I mean, how fortunate am I? What was it? The song by Tom Petty? I got lucky, girl, the day you got lucky and met me. And I'm thinking, friendship is the same way.
Yeah.
Yeah.
Yeah. So, I personally believe that every person should be respected.
Yeah. Oh, yes.
And the reason that I figured this out when I was 17, I figured out that a human being is in the image of God.
Mm-hmm.
And so if we're going to respect God, we have to respect every human being. So every human being merits respect, should be respected, should be listened to and appreciated.
Boy, come on, folks. That is worth the price of admission. You got it free. I love this because it is. And I think that when we begin to approach that, we can begin to approach, I think, the complex issues that are facing us right now, Claudia.
Mm-hmm.
I have pulled up for us, because I like doing this, working, let me get over here to a couple of articles that, some of these, by the way, were sent in by subscribers who listen to us.
Mm-hmm.
Here's one that I thought was really interesting, Claudia. Can cosmic rays affect cloud condensation nuclei by altering new particle formation rates? And this is a very interesting paper.
Mm-hmm.
The fact that they're now addressing the fact with the increased amount of cosmic radiation tumbling in, that it's actually now affecting the way clouds are actually formating.
Well, It is supposed to affect cloud. It is to increase cloud condensation through these cloud condensation nuclei, because the additional particles seem to create more cloud condensation nuclei. But all this research that they are doing is actually meaningless because of the chemtrail problem.
They address that in here, by the way.
Do they?
To address the coupling of cosmic rays and the CCN, we calculated the number and composition of aerosol particles as a function of particle size and time throughout the lower atmosphere, the troposphere, down to the lower stratosphere. So they're now acknowledging that whatever is up there.
Yes, but these aerosol particles they're talking about are natural aerosols.
Okay.
They're not talking about, they say it's aerosols because it's particles that are suspended in the atmosphere. And these would come from volcanic eruptions, sulfur particles. It can be salt if it's over the ocean, salt crystals. I haven't actually read a single article that mentions the fact that the Earth's atmosphere is actually full, because they chemtrailing every day.
No doubt about it.
So they're not considering that most of the clouds that we see everywhere around the world is artificial.
Yes,
it's formed due to artificial cloud condensation nuclei. It's mainly aluminium microparticles that they use. They're not natural.
Yes. And the reason why I'm pulling all these up, because it's all there. This article here, this paper, is dealing with the fact that the grow line is now, for Canada, is moving south. And they're talking about this as a result of, how should we say, more and more stuff in the air.
Yeah, this is actually very good that you're mentioning this, because I have just finished writing an article. I've made a video, but I haven't uploaded it yet because I've just finished it, where I realized why the weather in the United States is doing what it's doing, which is exactly what you showed there, which is the jet stream has moved south.
Yep.
And the reason why it's moved south is because the poles, the North Pole is warming up, not the South Pole. But the reason for that is because we expect the land masses to cool down and the oceans to warm up. And what we have over the North Pole is ocean. Why is the ocean warming up? Because of the volcanic eruptions.
Yes.
So all this lava is issuing from the volcanoes on the sea floor. So the oceans are warming up. Why are the land masses cooling down? Because the sun is cooling down and going dark periodically. I addressed that in my article. I'll mention it.
In fact, I have that paper pulled up. Is that the SDO?
Yeah, did I send it to you?
Yes, you did.
Oh my goodness, because...
Yes, so that's what I was leading up to.
Yes.
So very quickly, just to let everyone know, now, you see, I call this the IV drip. They're dripping the information out.
Oh, yes. Distant giant planet.
Yes. I mean, come on, folks. I mean, evidence, this is the Astronomical Journal, Dr. Albers. I mean, now they're doing the white papers now, published works on what we've all been saying, that you yourself have taken personally the attacks on a professional and personal level, but yet we can read papers like this and say, well, this is different. I don't think so.
Yeah, the thing is they still pointing only to the edge of the solar system. So it is soft disclosure, as you say, because they are starting to mention that it's possible for, say, a star to approach the solar system. They did that about one that approached some 70,000 years ago. Yeah. And now they say, oh, there's a planet at the edge of the solar system. Just at the edge, just look outside.
Right. I was trying to put there is what I was trying to, right out there on the edge, just right out there. We can't see it, but we think it's there. No. And I think that this one here is what really kind of took me around. So you got the debate, you got the dark matter versus the electrical universe. Electrical universe says that there are no black holes, where the other camp says, well, yes, there are. Now they're saying that apparently they've been able to actually track this, that there apparently are not a single concept black hole in the center of the Milky Way, but apparently tens of thousands of them.
Yeah. And you know what, Wayne? This is actually the opposite of what I have discovered is at the center of galaxies, because galactic nuclei are actually a lot like stars. They're just huge, and they most likely have a dense core, but the energy that these cores generate is always the same, from planets to stars to galactic nuclei. The energy comes from fission, unstable nuclei, very heavy nuclei that formed during the formation when light splits into particles, and then it fuses into very heavy nuclei. And then over billions of years, these nuclei fission and give off energy. This is how stars generate heat and energy from the core. Planets do the same. Galactic nuclei do the same.
And go ahead, doctor.
But there are no black holes, because a black hole would not allow a galactic nucleus to emit particles like stars do, and would not allow them to produce a solar wind. They produce a solar wind. All this gas that comes out from the galactic nucleus and forms the arms of a galaxy is all like the solar wind of a star. It's the same thing. The same thing that happens on the small scale is what happens on a large scale. Doesn't that make sense?
Listen, the way I kind of look at this, I take what you teach me and I apply it to what I read and what I can comprehend. And what I keep on telling myself is that we are witnessing a complete rewrite, rethinking of our whole way we view the universe. And I think mathematics itself in defining that universe.
Yeah.
I think
the thing is, most of physics has complicated the theories and how everything works. And they basically have done it on purpose.
Yes.
Because then normal people won't be able to understand what's going on, and they'll just think, oh, we'll leave it for the physicists. They know what they're doing.
Yes,
but
they do.
What they've done is made themselves the elite, basically. Only we can understand what's going on in the universe, and we will spoon feed the public a little bit here and a little bit there, as long as they understand, oh, it's all just too complicated, we'll just give you a little bit here and there. And then people say, oh, I understand that, but I don't understand that. But, it's physics. It's too difficult.
Well, it is.
But it's not supposed to be.
I know. I get it.
It's simple.
Well, like I say, I sit in awe. When I go outside, I'm in awe of what is going on. I mean, when you look at this, and I think that for myself, when I released myself from what I always called the tenements of my core, and realized that well, Steiger, it wasn't exactly right. So the best thing I have found is to listen with an open mind. And if I don't understand it, don't criticize it. Ask the questions. Why is it?
It's good.
Yeah. If I don't understand it, it has to be reasons. Why don't I understand it?
Yeah. You see, but most people, they complicate matters so much that people don't even know how to ask a question because they use terminology that is way above what people can understand. I mean, even physicists, just in a different field, if you go to a talk by someone else in a slightly different field, they use all this terminology and you start thinking, okay, what did he say?
Yeah.
When you realize what they actually say, it's actually not that difficult. They're just using long words to refer to certain things. But when you're new to it, you don't understand what he's talking about.
No, that's why they
just as well.
That's why they invented Candy Crush, because you're going, I can't understand a thing he's saying, but, and I've been in, it's like, okay. So I wanted to talk about this coronal hole, Claudia.
Yes.
This sucker is like a huge gash into our star. I mean, this is just amazing.
That's right.
You wrote a paper on this, so I'm going to hand it over to you.
I did write something on this. I thought it was worthwhile because I needed to explain one more time what's happening with the sun, and that is the stellar cores are absorbing matter from the sun. So the density in the corona is decreasing, and that decreasing density is causing the sun to produce areas of low pressure. In the same way that the Earth is developing areas of extreme low pressure, this is what we're seeing on the sun. It's the same thing. That's what these coronal holes are. The areas of very low pressure or very low density, basically it's the same thing. It's just a lack of particles in that region. And then it just opens up into, it becomes an area where not much light in certain wavelengths is emitted. That's a coronal hole. But the corona actually seems to stop the solar wind from coming out from below the coronal layer. So we get fast solar wind, which then impacts our magnetosphere. And because these particles are moving very fast, they impact heavily on the magnetosphere. A lot of them get through. They then impact our atmosphere, create currents in the ionosphere. And then these currents induce other currents in the interior of the Earth, leads to increased earthquake and volcanic activity.
Yeah, okay. And then, by the way, go ahead, doctor.
Sorry, just go ahead and ask what you wanted.
Well, no, what I'm beginning to understand that what you showed last week in doing the side-by-side comparisons was very revealing that, even the most skeptical of minds has to acknowledge that there is a visible change taking place.
Yeah.
And when you begin to realize that in this one today, and I was just kind of counting in my head, you could probably put about 50 to 60 Earths in this coronal hole.
Yes.
I mean, people don't understand that. I mean, these are huge.
They are huge. And the thing is, this one is just above the equator and it's Earth facing. So it's likely to impact Earth.
That's where we are right there.
That's right.
So we're going to get smacked. And, as I keep telling people, this is impacting, we're now understanding why people with more frequencies of these coronal holes, it's impacting health, cardiac, mental. We're finding that when if you're flying and you happen to be in one of these, what we call the solar wind, you're being bombarded with the equivalency of smoking about a carton of cigarettes.
Mm-hmm.
Yeah.
That's right.
Although I don't fly anymore.
It's not a good idea, I must say.
Yeah.
Plus, with the severity of the low pressures increasing because of the stellar cores orbiting the Earth.
I have that one pulled up, by the way.
Airplanes will start being tossed around in the air to the point that we will not be able to fly in them.
Listen, the military will never, ever, ever agree to this, but, when we begin to see an increase of particularly military aircraft that are crashing, you either say, well, it's because of the bad pilot, bad equipment, or something else is happening. And I thought about what you and I had a conversation once, that could it be that because of the weak magnetopause that we have and the increased amount of, what I call radiation, and I believe stellar cores do emit radiation, do they not?
Yes, basically, they would, yes. They would definitely emit radiation because they are designed to generate energy through fission. All objects do. And whenever you have fission, you have the emission of gamma rays. Plus, whenever these stars start being able to produce light once again, they will again separate the positive and the negative. They will have discharges. And you know that even lightning on Earth gives rise to the emission of gamma rays.
Yes, okay.
So whenever you have these electric discharges or lightning, for example, in Jupiter's atmosphere, it's just happening all the time because Jupiter is a star. So Jupiter will emit gamma rays.
Interesting.
Saturn will as well, but the sun will emit the most.
Yeah, and by the way, this book that I'm reading about Saturn is out there. Let me ask you something. I was thinking about this the other day.
Mm-hmm.
So we're beginning to see more and more what I would call anomalies, atmospheric. We're seeing, whether it be through photons, then that would be through, the aurora borealis. We're seeing different colors added into the spectrum. The thing I was going to ask you, is it possible that we could see formations of, I want to say, you could say pockets, you could say maybe even vortexes of where we would begin to see plasma anomalies?
We most certainly will, and most likely have been seeing them. Because if we have stellar cores approaching the Earth, the first interaction will be electrical. They will absorb electrons from the Earth. They will, whenever two isolated celestial objects approach each other, first of all, they have different amounts of electrons in their outer layers. So they have different potentials. So as they approach, what you will get is the zapping between the two. This is the same thing that happens to us when the air is dry, and sometimes a person just
electricity.
Other because we have different potentials. There's a zap, a discharge going across.
My wife and I
catch something.
It's so bad here, we have to ground each other's cheek before we kiss. True story. Just
really?
Last week, I gave her a kiss. I think I burnt her lip. There was an actual spark that we could see. I said, baby, I still got it. But anyway, getting back to more serious. So
that's a very good example, Wayne. This is what happens in space whenever two objects approach. What they will do is equalize their potentials first. After that's done, they interact gravitationally.
So my next question is this. Would that not also generate a temporary electromagnetic field in itself?
Yes, what happens is when two objects approach, their outer electron layer combines so that they get one whole sheaf of electrons going around both.
Okay.
And so this is but the stellar cores are different from normal objects because they're old objects. They don't have an outer negative layer. They have a neutral layer instead of an electron layer. That's why they don't develop a tail, a comet tail when they come into the solar system. They never observed until they get to the sun. When they get to the sun, then they start interacting with the sun's electrons that are in the sun's corona.
I have another question for you, and this goes back to my video post-production days. We have discovered a material that absorbs light. It absorbs photons, and it's so dense that you can't see visible photons coming through it. And that's how this material absorbs light. My question, doctor, is this. Is it possible within the constraints of what we understand in physics today that there could be a material, and I was thinking of these stellar cores, that would be made of a material that would also just absolutely absorb light, thus making them appear to be invisible?
The invisibility is possible. In fact, it is possible, and in fact, the technology is being used on Earth. Let's put it this way. Because I have actually written an article where I saw the craft that was being used in the sky to do the chemtrailing. And obviously, this was an object that had a cloaking technology. And a cloaking technology means that the object can be made invisible. In other words, it's made to either bend light around it or actually use holographic projection to cause whatever is behind it to be projected on the front. So there are different ways of doing it. But you can do it electromagnetically, definitely. But the other thing I want to mention is what you say about matter has light within it. Matter is made out of light. When a photon splits, okay, so I didn't even explain that the first diagram we had right at the top explains what happens with the sun in the sun's corona. So that was the first diagram right at the top at the beginning of this document.
Right here?
That one. You see, this is what happens. The photon splits into a proton and electron. Why does it do that? Because the sun is positive on the inside, negative on the outside. That creates an electric field and a potential difference across. And that causes a discharge. Just like, if you have two electrodes, one is at a low potential, one's at a high potential, you're going to get a lightning bolt across. So that's what causes these discharges in the sun. The sun is continuously having electrical discharges or lightning within it. This lightning releases photons. If the photons are of the right energy, they immediately split into particles. They become particles. But the rest of the energy in the photon splits up and goes into the two particles.
Okay.
So part of the energy of the photon goes into mass, and part of it stays as non-mass energy, which is a photon again. So, and photons are actually the same thing as heat. They will even give a particle the ability to vibrate or move very fast if it's gaseous. In other words, photons are heat, energy, everything that causes a particle to move faster, and that's basically what heat is, comes from energy, which is a photon. Energy is not an abstract concept. It's actually a photon.
Both of these interactions here, the electrostatic and the gravitational, will generate heat within themselves, correct?
The electrostatic doesn't. The
electrostatic does
electrostatic is
not.
a very simple interaction. It is what causes photons to turn into particles.
Okay.
But it's not associated with energy itself. It just causes the discharge to happen because of the fact that you have positive and negative charges. It never changes in strength. It's always the same strength interaction. It doesn't change over time. That's why the stellar cores will still interact electrically with other objects the same way they did when they were young stars.
But there's being energy that would be displaced by the splitting of the photon, right? I mean, the proton. Okay.
The energy is always gravitational in nature.
Okay.
So the two interactions act together. That's why I call this unified theory of electro-gravitation, because you cannot have just one interaction acting on its own. We would get no universe if we only had the electrostatic interaction, because if we did, then the moment we have a proton and an electron, they attract each other. So they would collapse into each other, and we would just have neutral particles. And then we'd have no energy transformation mechanisms if that was to occur. But the gravitational interaction causes the opposite. It causes them to separate.
Interesting. Wow. I love this. Do you know the hour has come and gone?
Yeah.
This is nuts.
But
go ahead.
I just want to mention one thing, Wayne, before we end. I don't know if you ever watched Star Trek.
Oh.
You did?
Yeah.
I used to love Star Trek when I was young. But one of the things they have in Star Trek is these food replicators, where you can just walk up to it and say what you want, and you open a flap and there it is. So basically what I have discovered is what the universe is like. And now the technology is possible, except you need very high energy gamma rays to turn photons into protons and electrons. And then by applying the right electric fields, which would be computer generated, you can then place the protons and electrons in the right position to form the right molecules to therefore create, with a replicator, this is basically replicator technology, anything you want.
I see this, because this would have a structured makeup. In other words, there would be a formula that if I could duplicate this mathematically, applying the principles that you just said, it would produce me a pen.
Yeah.
Wow. That's cool. Hey, you better not let this out. I know some venture capitalists that would love to talk.
I actually quantified what you need, and it's quite a high energy gamma ray that you need, but it's not impossible with the technology that we have. And the potential difference we need is also very high, but I don't think it's impossible either.
I know of another physicist, Dr. Miller, that would agree with you on that. That, in fact, it's, if you study comparative religious studies and you also look at the archaeological record as well, we know that the ancients, particularly the Phoenicians, figured out that language was basically 12 octaves. It was 12 tones, harmonics. It's where we get, phonetics. And I've often now, where we're discovering that they understood how they could then begin to manipulate frequency to matter, to light.
Yes.
I love
That's
this.
right. Sound is very powerful, actually. The human body seems to, and organic organisms respond a lot to sound. It's very powerful. especially when it forms these standing waves or these harmonics.
Okay.
So
I know you don't watch a lot of my videos, but I practice every morning in the shower what I call spirit talking, but it is I've had a number of people tell me that it's full chakra activation, but I do that by emitting sound and water together.
Okay.
Very powerful. Very, in fact, I'll just share this with you as we kind of close out. This morning, I'm going to have to put something there because it got so powerful that the water actually begins to vibrate.
Wow.
It's very interesting.
Yeah, water itself is extremely interesting. It's almost like a living thing because of the fact that it's a dipole. So it responds to electric fields within the Earth's atmosphere. It's actually the electrical conductor in the Earth's atmosphere is water.
And don't we generate 20 watts of an electrical field around us, which, and I'm just learning this by osmosis, just trial and error. No one's teaching me. And lo and behold, when you start stumbling in on this, I figured out how Tesla did it, how Einstein, how, Freeze, all of them, the great minds, Dr. Claudia Albers, how they begin to think and how you can begin to manifest many of these principles into the physical realm. So that's what I enjoy. Well, folks, I hope everyone's enjoyed it. There's 240 people in here. I guess people are enjoying it. This is truly, this is truly class. I mean, I learned so much in this, and I know other people do. I read the emails, and I forward you a lot of them that come in. People are learning here.
That's wonderful.
I tell them that if you have children and you have grandchildren or whatever, and you want to teach them about physics, this is the place to do this.
Yeah.
How rare do you actually have the opportunity to have an actual teacher that has actually did the work to get the parchment? That's all I got to say. People want to get all wrapped around the axle,
Yeah.
Why did she say that? Why did she say that? And I said, I tell you what, Cupcake, get off your pony there and you just step up and you just show me that PhD that you got. And if you can show me your PhD, then I'll let you go ahead and talk to the doctor. It ain't going to happen because we all know, learn respect. I think about this, Claudia, I had a 9th grade algebra teacher, Mr. Schwartz, and the guy was a jerk. I think he had something against my name. I swear, his was Schwartz and mine was Steiger. And it was, anyway, I mean, as much as I thought that he was a jerk and much as I may have disagreed with him, I respected him.
That's good.
I respected him. And that's what we have got to teach these people who come in for whatever sources they're coming in and they have a dispute or a disagreement. I don't care if you have a disagreement, write it out rationally. I'd be more than happy to send it over to Claudia, but do it with respect.
Yeah, the trolls, of course, will never, they don't really have a dispute. They just want to shut you up and tell you something that will upset you. They do it on purpose,
They're not here. We just absorb them in love. We just say, it's okay. Come on. What you need is a big hug. And then I tell them,
relax, calm down now. Don't stress. Take it easy.
And then we all go and smoke the pipe. No. I love it. So Well, Claudia, I will see you next Monday night. I hope you have a good week. Anything you'd like to tell everyone before we go?
Well, thank you for being here. One thing I've forgotten to mention, Wayne, is that I pray a lot.
Good. Nothing wrong with that.
If I don't know the answers, I ask someone who does.
Always good advice. Always good advice. You know, what I always refer to, the answer lies within. That's where it's going to come from. Yeah. I haven't ever seen it. There was a movie, Claudia, you and Scott ought to watch, called The LA Story. It's got Steve Martin in it, and you'd absolutely love it. And here's my point. You know, I never had the highway sign stop me and tell me it was going to deliver to me great knowledge. And that's what happens in the movie.
Okay.
Because it always comes from within. Yeah. Well, okay. Thank you.
Thank
everyone.
You. It was lovely. And as usual, the time just...
It does. It just flies by. I mean, I feel like sometimes I'm stepping on the amusement ride, like at Six Flags. You know, you're going to do the roller coaster thing. And you're enjoying the crap out of it, you know, up and down, and you're going around, and then you pull in and you're going, what happened? Just goes that quick.
I know. Yeah.
Oh, it's just so good. Okay. Everyone, we appreciate all the moderators. Thank you so much. Everyone that came and visited and stopped in, thank you for your support. Thank you for your kindness and the respect. And this is how we all learn. So, Dr. Albers, until next week, I will see you then.
I'll see you.
Stay with me before we go off the air. Eric, now I've been told that this is being cut off sooner than apparently we're still talking. So what I'm going to do is I'm going to give it, Claudia, let's you and I stay on for a 10-second delay. So, all right, everyone, we will see you later on this week.